We have an example problem here. A mother hawk screeches, her frequency is 800 hertz, as she dives at you. You are running away from the hawk at 4.45 meters per second, but you hear the screech at 873 hertz. How fast is the hawk approaching? So just to get a visual of some sort, we have the hawk, just using a dot to represent the hawk, diving at us. She is the one screeching. We're trying to find out how fast she's traveling. Since she is the one emitting the sound, we use V sub s for the mother hawk. We are running away, or you, V sub o, the observer, is us. 4.45 hertz. Nope, not hertz, sorry. Meters per second. So the mother hawk's frequency is 800 hertz, so this would be our F naught, the actual frequency being emitted. 873 is what we're hearing, so this would be our F plus minus. All right, so the equation, the Doppler effect for sound. F plus minus, the frequency that we hear that's higher or lower because of motion, is equal to F naught V plus or minus V sub O over V minus plus V sub S. We can solve this all symbolically. I prefer to plug in my numbers for this particular equation now, just to remember what I have and what I'm looking for and get my numbers correctly. It's how my brain works in this specific situation. So I know that we are hearing 873 hertz. The actual frequency, we're told, is 800 hertz. V without the subscript is the speed of sound. Because we have not been given a temperature, we're going to go ahead and assume the 343 meters per second. The observer, that's us running from the hawk, we know that is 4.45 meters per second. V sub s is what we're looking at, the source. We want to know how fast this hawk is traveling. Now, in terms of the signs, as up here, the observer, we're traveling away from the hawk. So we need the bottom of the two signs listed in front of V sub O, the observer. The hawk is moving towards us, which means we need the top of the two signs, so the negative sign in the denominator, because motion towards is the top of the two signs. We determine the signs in the numerator by what the observer is doing. We determine the signs in the denominator by what the source is doing. And so our only unknown here is the speed of the source. So to get that to the top, let's see, we can multiply up. Sorry, there's a serious lag on my computer right now. Let's see here. Okay, so 873. If I bring up that whole quantity of 343 minus V sub s, that leaves me with the 800 times the quantity of the 343 minus 4.45. Maybe I'll go ahead and divide by 873 while I'm at it, just to decrease how many numbers I have to multiply and whatnot. So on the left, I will have 343 minus the speed of the source. On the right, I can figure out what that number is. So multiplying everything through, I'm getting 310.2405 on this right side. So V of the source, the hawk, I just need to subtract that 310 to the other side. So 32.759. Significant figures, I'm going to assume the 800 to be 3 sig figs. 4.45 is 3, 873 is 3. So my answer, the speed of this hawk would be 32.8 meters per second, which is pretty close to 70 miles per hour. Very quick, very fast.